This chapter is titled Eulerian and Hamiltonian walks, and in this particular video we're going to focus on what are known as Eulerian walks. Now the first thing we're going to talk about is the pronunciation of the word Eulerian. Eulerian trails and circuits are a concept first discussed by someone named Leonhard Euler. Here's his name here. Now Leonhard's last name is not pronounced how most people think it is pronounced. It is not pronounced Euler, which is what a lot of people think. This is the incorrect pronunciation. You've got to pronounce it Euler and think of the stuff that you put in your car. So the word Eulerian, which comes from his last name, is pronounced as I'm saying it, Eulerian, like the stuff you put in your car, not Eulerian, which is what a lot of people think when they first see it. So we'll talk about what Eulerian trails and circuits are. Now, Eulerian trails and Eulerian circuits are basically the same thing. They are trails that use every edge of a graph only once without repeating any. That's the same for trails and circuits. There's one difference between them is that a trail starts and ends at a different vertex. It's written here. So they start and end at different vertices, while as with a circuit, they start and end at the same vertex. So that's the only difference between trails and circuits here. Now, why is this useful? Well, it's very useful for something such as mail delivery. A postman or postwoman would ideally drive down every street only once delivering mail. This is to save time and money for the post office. So if we look at the map on the right, we would represent every intersection as some sort of a vertex, like so, and the post people will try and make a trail or circuit that passes down every road only once. So let's just have a quick go at it. We'll go in green. Let's say we're going down Myrtle Street and then down Spring Lane up here. And you'll soon see that looking at the trail that I'm taking right now, that eventually I have to pass through the road a second time. So the postman or woman is actually losing some time because they had to pass through a road a second time, especially here where they've got to get to what is known as Spring Lane. So we're trying to minimize the amount of streets that we're passing through. So how do we know if an Eulerian trail or an Eulerian circuit exists? Well, what we need to do is find the degree of each vertex. Okay, so we'll start by looking at this vertex here. This vertex has a degree of 2 because 2 edges connect to it. This vertex has a degree of 3 because 3 edges connect to it. This vertex has a degree of 3. This one has a degree of 3. This one has a degree of 4. And this one has a degree of 2. And I should have put another vertex down the end of Spring Lane to show where the lane ends. And this one here has a degree of 1. Now, if an Eulerian trail exists, you will find that 2 of the vertices on the graph have an odd degree, meaning that the rest of the vertices have an even degree. So if we look at our map here, how many vertices have an odd degree? We have 1, 2, 3, 4. We have more than 2. What that tells me is that because there are more than 2 with an odd degree, an Eulerian trail does not exist. Okay, let's look at an Eulerian circuit. For an Eulerian circuit to exist, we need the degree of every vertex to be even, which is not the case for this map. We've only got 1, 2, 3 vertices with an even degree here. So we can quite safely say that there is no way that the postman or woman can go down every street only once for this map.